In these next questions, we're dealing with what are called linear equations. And this is a subject that's going to come up again and again in algebra because linear equations are very useful. Now, the word linear means line. So these things, when you graph them, they make straight lines. An equation, well, it's got the EQUA, that means it's going to have an equal sign in it. For a graph to make a line, it's going to look something like this, an equation to make a line. It's going to have an x and a y. None of these are going to be squared or cubed or anything crazy like that. It might have another number there, but it's definitely going to have an x and a y and maybe some numbers multiplied by it, maybe some other numbers hanging out there. There's a particular form that is useful for linear equations because it'll help you put them into a graph much more easily, and it's called the Slope-Intercept Form. And basically that form is y equals mx plus b. That's how we think about it. The y and the x are the variables, the m and the b are numbers, and m represents the slope, and b represents the y-intercept, which is where the line crosses the y-axis. So the question here is, it says write 3x plus 6y equals -4 in slope-intercept form. So how do you do that? Well, you want to get y over on the left and everything else over on the right. So we're going to do, well, in this case, we're going to take this 3x first and we're going to move it. You're not really moving stuff. All you're doing with algebraic equations is you're adding, subtracting, multiplying, dividing, etc. But it has the effect of moving this 3x. Let me show you how to do that. I'm going to write it over here. 3x plus 6y equals -4. What I'm going to do first to move this 3x is just subtract 3x from this side. It's going to cause it to disappear over here, right? Because they add up to 0. Of course, I have to do the same thing on the other side. Once I do that, these are gone. I've got 6y left over here. And over here, I'm going to write the x term first because that's closest to the slope-intercept form. I've got a -3x and a -4. So I'm pretty close now. I've got the x term and the number term over on the right. I still got the 6 multiplied by the y though. And to put this in slope-intercept form, we need to get rid of that 6. And this is just like solving for y. We're going to do the opposite of what's being done here, which is 6 is multiplied by y. So we're going to undo that with division. We have to divide the whole side, though, on the right. So that's also divided by 6. When you do that, the 6's disappear. You get y by itself, which is exactly what you want. And then what I'll do is take each of these terms and divide them by 6. I don't want to leave it in this fractional form here. I want two separate terms, and the reason I want that is because I want to easily look at what's in front of the x and know that that's the slope, and I want to easily look at this number and know that that's the y-intercept. So -3x over 6, let me write this over here, y equals -3x over 6. Well, that can simplify. 3 over 6 is the same as 1/2, and then let's see, we've got -4 over 6. That simplifies to, I can take a 2 out of each, I get 2/3. So what I get is y equals -1/2 x minus 2/3. That is slope-intercept form. Let's try one more. This one's got a little trick in it. On this one, I've got the 5x over on this side, which is kind of what I want. So that's in the right place. Because remember, we're going for y equals mx plus b. So we want that x term to be over here on the right side, and it is. That's good. I've got the b in the wrong place. This is my b term, this plus 10. And I want that to be over here. So I've got to get rid of it. And I'm going to get rid of it by subtracting 10 from both sides. Over here, it makes it disappear. Over here, I'll just get, well, I'll get -y is what's left over here, and then equal sign, and 5x minus 10. And you might think you're done there, but you're not, because there's a negative sign here. And this can't have a negative sign. We need just plain old y. When you see a negative sign in front of a variable, another way to think about that is that it's multiplied by -1. And so what we're going to do is divide by -1. And same thing on the other side. When I divide by -1 over here, a negative divided by a negative becomes a positive. Y divided by 1 is just y. So it just becomes y, which is exactly what I want. And over here, the effect of dividing by a -1 is really just to flip the sign of each term. So instead of a positive 5x, which I had, it's going to be negative 5x. And instead of a -10, it's going to be a positive 10. So my final answer here is y equals negative 5x plus 10. We got one more to look at. This one gives you an equation that's in slope-intercept form and asks you to identify the graph. Couple of things. This is y equals mx plus b form. The b here is the y-intercept. So this line should cross the y-axis, that's the axis that goes up and down, at positive 2. And let's just look at these. It looks like in A it probably does. It crosses that line a little bit above the x-axis, so it's at positive 2. This one's at, looks like it crosses it at positive 2 as well. This one looks like it crosses down here at -2, so this is not it. Same with this one. Crosses at -2. So we've already got this narrowed down just by looking at the y-intercept. The next thing to look at is the slope. And a couple of things you want to pay attention to. You want to pay attention to the sign, whether it's positive or negative. And positive slopes will go up and to the right. Negative slopes will go down as they go to the right. So that's a negative, that's a positive. And then this number, basically the bigger that number is, the steeper it gets. A slope of like this one would be a positive 1. This would be a negative 1. Anything steeper, so that maybe is a positive 2 or 3, and here's a negative 2 or 3. This is a positive 5, so it's going to go up and to the left, and it's going to be pretty steep. This one goes down, up and to the right. This one goes down as it goes to the right. This one goes up as it goes to the right. So we know that's it. Now those are a couple of rules to remember about the slope. If you couldn't remember those, there's another way to check this. You can plug in a couple of points. We know that the y-intercept is 2. The reason that is because we think of when x equals 0, what's y going to be? Well, when x equals 0, that's right here, what's y? We put in 0 here. 5 times 0 is 0, y equals 2. So there we are at 2, so we know that's right. We could try putting in another point, though, and the point I like putting in is when y equals 0. So let me rewrite that. Instead of y, I'll put in 0 equals 5x plus 2, and then I want to solve for x. I'm going to subtract 2 from both sides. I get -2 equals 5x, and then to solve for x I divide by 5. So I get x equals -2/5. So a negative number. So when y is 0, which is where it's going to cross the x-intercept, it should be just a little bit on the negative side of things, which is right there. This one, where y equals 0, it's a little bit on the positive side of things. So you can always plug in points and try to test them. In fact, you can if you see a point that looks like the line crosses it, you can plug that point in and see if it works. This one right here, I've got 1 and, let's see, 1, 2, 3, 4, 5, 6. 1 and 6 sort of looks like it works, or maybe that's 1 and 7. So the point 1, 7. And if you find that point, remember this is the x, this is the y, and then you can go ahead and plug it into your formula. So if y equals 7, then 5 times 1 plus 2 should equal that. Well, 5 times 1 is 5 plus 2 is 7. You get 7 equals 7. So you find a point that looks like it's on the graph, you plug it in, and it checks out. That's another way to know that this is the right answer. So that's some work with linear equations and slope-intercept form.